Hello everyone. In this video, I'll be talking about statistical analysis for output using the small manufacturing plant where entities movement depends on particular sequence depending on its type. I have uploaded a video where I have shown how to build this transfer based on sequence. So I'll be using the same model to outline how we can do statistical analysis for steady state operation for a system. So in these small manufacturing plants, there are three types of part with a probability, with certain probabilities that are getting in and then moving around this facility. One constraint is that part will move clockwise. So if it's in cell 1 and it needs to go next to cell 4, it will follow this route. Though it's longest, but it will follow that. It won't come from this side anti-clockwise and reach cell 4. That is one constraint. And the second thing is that in cell 3, we have two machines. One of them is new, one of them is old. So in this table, we had the processing time for cell 3. Not part 3, sorry. Processing time for cell 3 was given for new machine. So for old machine, we had to, the processing time was given for the old machine. So the new machine was 20% faster. So we had to multiply the process time with 0.8 and so on. I would suggest you to watch the first part of this video before watching this and building this model. It will make more sense then. So we'll be using the same facility. And the scenario is as such. So using model 7.1 as base, we're going to change the number of replication from 1 to 10. And we're going to change the replication length to 5 days. So let's go ahead and do it step by step. So I'll go to Arena. So this is my model 7.1. So I'll go to files and I will save this inside my folder called online videos and I'll label it as 7.2. Yes, I do. Okay. And then I'll go to run. I'll go to setup and then I'll change my replication length to be 5 days and replication number to be 10. Replication number to be 10 and run length to be 5 days. All right, so I have done that. And the facility is running for 24 hours. Then I'll go ahead and click OK. So before we progress and make small changes, let me discuss one thing. So far, we have considered terminating simulation, where there is a definite starting and stopping criteria for a process. So let's say a bank is starting from 9 a.m. and it's going up until 5 p.m. and then entities are getting flashed out. Or maybe it may be a Cineplex. It may be an outpatient facility and so on. Think about what happens to emergencies. Or think about assembly line where entities doesn't actually moves out of the system, right? They stays there. So the operation is continuous. So in those kind of operations, people are more how to say that, people are more interested to find the long run behavior of those systems. Let's say assembly line for an aircraft and so on. So people wants to know, or the manager wants to know, how the system will behave in long run. So in those cases, how we can use simulation, how many replication we have to run before the system reaches steady state. So how to find that? So in this video, I'm going to demonstrate that. So what I did over here is that I went to run and then changed the replication length to be 5 and number of replication to be 10. Next, we're going to create a statistics called total WIP, which is a time persistent statistics. Why it is time persistent? Because though we are doing a discrete event simulation, every time whenever there is a discrete change, the work in process in this simulation model will be looked into. So Arena will look into this at every discrete point of time change. If it was a tally statistics, let's say for finding the average waiting time for parts in the system, what Arena would have done is that it will trace a part from beginning, from its creation up until its disposal, and then said, okay, the part entered at this time or created at this time, it went out this time. And this is the total system time for part 1, part 2, and part 3. So it's a tally-based statistics. It depends on the entity itself. So whenever the entity is in, Arena tracks it down. And when it leaves, it's done. And then it tracks the other one and so on, whatever entities is inside the system. But for time persistent, this kind of stats like utilization, work in process, average number of waiting in a queue, and so on. So time average number of waiting in queue and so on. These are time persistent stat. Or let's say, if you think in this way, that every time there's a change in time, so an event happens, Arena tracks down this statistics for us. That's why it's time persistent. I will definitely refer to read the textbook to get better idea, or any other reference material. So we are going to build a time persistent stat, and we're going to track the total number of work in process in the system. And we have seen that we have split it incoming parts into type 1, type 2, type 3. So we have to add up all this to track the total work in progress of parts inside Arena. And then we're going to take an output of this file into a DAT file labeled as total WIP history. And then we're going to build another stat. Sorry about that. I'll name it cell 3 process WIP. So in order to track down the work in process inside cell 3 station, we're going to build another statistics, and it's going to be also time persistent statistics. Why we're building these two statistics is basically trying to see how these statistics changes over time in the simulation model. And in the initial stage, as we are starting it empty and idle, like there is no entity at time 0, what happens is that there will be a biasing. That means it will take the system some time to reach a particular steady state. So we have to figure that out, like at what particular time a system approximately reaches a steady state condition. At what particular time we can collect statistics from Arena's output that would truly represent the steady state condition. So that's what we want to figure out. That's why we have taken the output of 2 time persistent stat, and then we are going to feed it inside a output analyzer, which is another inbuilt tool in Arena that we can use for doing different kinds of analysis, for comparing 2 or more systems and so on. So let's go ahead and input these 2 new statistics in Arena, and let's try to figure out what should be our warm-up length. Let's go to Arena, and then we'll go to advanced process. Here we'll find statistics. So in the first one, we have created a statistics called throughput, which is simply like where I have added the total number of part type 1 that went out of the system, total number of part type 2, total number of part type 3 that went out of system, over the total number of part that entered the system times 100. That gives me the throughput of it. Why we have selected stat as output? Because if we have selected, let's say, time persistent, that every specific time Arena would have reported the statistics. But do we really need that discrete utilization for every point of time when there was a change? Maybe not, because I'm more interested what happened at the end. Okay, 10,000 parts got created, 8,000 of them got disposed. So 8,000 over 10,000 times 100, that gives me the throughput for the system. That's why we have selected output. So any kind of statistics which is defined as output would be evaluated by Arena at the end of simulation run. So it won't calculate these statistics in between. And if you think of a larger model, it will make it faster. The more stat you want to get from Arena, it makes the program a little slower. For these small, teeny models, it doesn't matter. But if you think of real system, it does matter. And it also depends on what you want to collect. Like I want to collect the throughput, the overall throughput. So I don't need to go over at every point of time. If I had, then I would have selected time persistent, or maybe I would have got hourly throughput and so on. So this time, that's why I selected output. Double click over here. So let's go ahead and create the first statistics that we need. So we'll name it total WIP. And the output type would be time persistent, because I really want the time persistent stat, because based on this stat, I'm gonna define my warm-up period in Arena. I'll say Arena, okay, fine. Run for 10 days, but the first 2 days doesn't represent the steady state condition for my system. So I don't want any stat based on that. I want stat after that, and so on. So I'll go to expression, I'll go to build expression, and then I'll browse basic process variables. I'll go inside entity, and then I'll select entities WIP part 1 plus entities WIP part 2 plus entities WIP part 3. So if the parts were not categorized between part A, B, 1, 2, 3, or part type A, whatever, like part A, part B, part C, what we could have done was that just come here, got entities WIP for parts. That would have made, but here we have separated parts. That's why we have selected these 3 expressions, and these are inbuilt things. Sorry about that. Inbuilt things in Arena, inbuilt variables that tracks things for us. Let's go ahead and click OK. And over here, the report level in your report would be total WIP, which is totally fine. However, additional thing is that we need to define an output file where Arena will deposit the time persistent stat for WIP, total WIP. And we need this file to feed it inside output analyzer. So let's go ahead and let me go to my desktop. I'll go inside my online video, and over here, let's just name a file called WIP history.dat. And then I'll hit open. So I don't need to create a file before. So what Arena will do is that it will create the file by itself. That's a very good thing. You don't need to like go back and forth, create a date file, come back here and do it. You can just do it from here. You can just create a new file from here. So that's a good part. Let's go ahead and create our another statistics we want to collect. We want to collect cell 3 process WIP. And this is going to be also a time persistent statistics. And then in expression, let's go to build expression. And here we will browse process under basic process panel, and then we'll select number in process for cell 3 process, right? Cell 3 process, we are interested in only this one. So I'll select OK. And then over here, the report label will be cell 3 process WIP. And over here, we're going to create a file called cell 3 process WIP history.dat. And then just hit OK. Let's go ahead and save this file. So I'll go to run, setup, I'll go to project parameter, and I'll just label this project 7.2 and describe it with total WIP and cell 3 process WIP stat. And I'll hit OK. I'll save the file. Next thing I'm going to do is I'll go back to run. I'll go to run control, and I'll select batch run with no animation, because we have declared that running for 5 days, 24 hours for 10 times. So it's going to take a long time if we don't select batch run. So let's go ahead and do that, and let's run our model. So it's running for 10 times now. Let's go ahead and hit yes, that yes, we want to know the final output. So small manufacturing plant. Okay, so this is our report. Let's go in here. Let's go to time persistent stat. So 2 time persistent stat has been reported here. So let's go ahead and keep a track of them. So total WIP without warm up is gonna be how much? Let's see. It's gonna be how much? 15.3505 plus minus 4.42. Okay, 15.3505 and then simple plus minus would be 4.42. So this is my average WIP or mean, and this is the half width. All right, 4.42. Now let's go ahead and open Arena's tool called Output Analyzer. So you cannot browse Output Analyzer from within Arena. What you have to do is you have to go to search bar and type in Output Analyzer. If you have correctly installed Arena in your system, you should have this tool over there. So go there, type in output, and then you'll have Output Analyzer. Double click on the app shortcut. Then you will be directed to this. This is more or less like an input analyzer or process analyzer and Opquest and so on. So let's go ahead and hit that we want to open a new file. Go to file, save it, and then let's just save it where we have saved our model inside online video. We'll name it model 7.2. That's it. And now we have to input our data files or our DAT file that we created. So I'll hit add. And now I'm inside my online video folder where I asked Arena to create this file. So I'll select the first one and then I'll click add one more time. And then I'm going to select my total WIP, which is my second file. So make sure you are referencing the right file. So let's go ahead and select the first file, which has all the data for cell 3 process WIP. And then let's go ahead and hit plot. Just give me a moment. Okay. So I just increased my icon size. So let's go ahead. So select the file with the stat for which you want to plot. So I'll select that and go ahead and select plot. Next, I'll be directed to this interface where for plotting, Arena is asking me which data file it needs to work on. So I'll hit add and then I'll select this one. So it's a little bit tricky to see, but make sure you have referenced the right file. So this is the file with cell 3 process WIP data, and I want to see the progression of the statistics over all the replication. That's why I'm going to select all, and then I'll select OK. And over here you can see we can title this graph, we can title our x-axis, we can title our y-axis, and then we can also control like from what time to what time we want to zoom into the graph and see, or the plot value from what to what we want to control. Let's just make Arena decide that, like we want everything for now, but you will come back and we can zoom in a particular area to decide better what should be our warm-up period. Let's go ahead and click OK. So then this graph will be created for us. So over here we can see that all the 10 replication has been used, and then Arena has plotted this graph for us. So I want to mention one thing, that what is steady state condition? It doesn't mean that system will not change at all. It means system will reach a harmony where its pattern will be repeated. All right. So it doesn't mean that all this value will get flat and so on. It won't change at all. It will change, but the change will be steady. So over here for replication, I think this is replication 6. It has a little bit of overshooting. Apart from that, the stat has been consistent within a certain range. After what time? At from 0. So this is why x-axis is in unit of x times 10 to the power 3. So this 2 means 2 times 10 to the power 3, which is 2000 minutes. So this is like 500 minutes. This is like 1000 minutes. This is 1500 minutes. This is 2000 minutes, and so on. So we can see that if we like think of plotting something, we can see after reaching this part around 2, like the system has started repeating itself into a harmonious pattern. Though there is a small overshoot, but that's fine for one replication. However, it has been consistently repeating its pattern. It has reached its steady state or long-run behavior. So we can tell Arena, okay, so run the system from 0. However, when you reach 2000 minutes, or let's say to be optimistic, let's say 2 days for this data, wipe up all the statistics up until from 0 to 2 days. Why? Because up to this, the system needs to get warmed up to reach steady state. So from this plot, we can find the warm-up period. However, you might have a conflicting number. Let's say for this one, we are considering cell 3 work in process. Let's just minimize this. And let's just go ahead and try to plot the same thing. I'll hit plot. And over here, I'll add total WIP data for all replication. And then I'll click OK. Okay, sorry about that. So I'll go back. I'll plot the data. And I'll take off the first one. And now I have the total WIP, and then see here, the plot is for total WIP. So when I look over here, it has also reached a steady state pretty much at the same time, right? At 2000 minutes. So we can see that these two statistics are reaching steady state at the same time. However, you might have conflicting numbers as well. Let's say for total WIP, maybe there might have been more overshooting, or it might require more time. Let's say 4000 minutes to reach steady state. And cell 3 work in process, let's say, just takes around 1 day to reach steady state condition. So in that case, always takes the maximum number, because we want all of our stat to reach steady state. So cell 3 reached steady state after 1 day, that's good. However, the other one didn't. In Arena, we can just specify one warm-up period. So that's why we will always take the max one. So let's go ahead. So we have this plot. Let's go ahead and go back to Arena. Let's save it. So let's go to run setup. And over here, let's go to replication. In replication, we have replicated for 10 times for 5 days, and the warm-up period is 0. All right. Let's go ahead and define our warm-up period to be 2000 minutes, because approximately by eyeballing, I can say this small system has reached steady state by 2000 minutes of its operation. So every replication from 0 to 2000 minutes, Arena will collect the statistics. However, it will wipe it off for generating all the statistics in the report, because maybe the simulation analyst wants to know the steady state condition, steady state statistics for the system. So that's what we have done. Let's go ahead and click OK. Let's go ahead and run our system. Yes, I want to see the report. Let's go ahead and go to user-defined time persistent. So here I want to collect the total output Now the average is 16.1267. 16.1267, and then plus minus 5.81. 5.81. So think for a minute. Between these two values, what has changed? The mean has shifted, right? The mean has increased, as well as the half width. Think about it. Arena is wiping off 2-day data from each replication. So if we have 10 replication for 5 days, that means we are running it for 50 days, right, in total. And from there, Arena is wiping off 2 times 10, 20 days data. So this is based on 30-day data, right? So we have less number of statistics for this, for total WIP, as it is a time persistent stat, it's not output. So what we can see is that we are wiping it off. That's why our confidence interval is increasing. So if our half width is more, what does this mean? It's less precise, right? So though we are using computation time, however, just to get the steady state data, we are having some issue with half width. So there is another way we can define Arena that, okay, fine. Instead of running it for 10 times for 5 days, let's go ahead and run the whole model. Let's go to run. Let's go to setup and run the whole model for one replication for 50 days. All right. What is negative about it? Arena is going to use within replication data for estimating variance. It's not gonna estimate the variance based on cross-replication data, based from different samples. It's gonna use its own data and then it's gonna estimate the variance, which is not that good thing. Why? Because there will be correlation between data, right, within one replication. However, if we run it for a longer period of time, Arena does its own batching. So what it does is that it has a long replication, let's say 50 days, and then it tries to group certain period of data by itself, by its internal mechanism. And then within those batches, it tries to find the mean, and then like right in that portion of time, batches are treated as replication. So let's say batch 1 is one replication, batch 2 is another replication, and so on. So it does that internally to give us the half width, and it tries to make the half width possible without correlation. However, for that, we have to really run the model for a long time. I won't talk a lot about it because I would refer you to read the textbook, because over there they have really defined well, like how long you have to run your replication length to have unbiased or uncorrelated half width and so on. The best part is if your data is correlated between batches, Arena will report that your half width is correlated. And there is another statistics test that Arena goes through to decide that. So you can go ahead and check your textbook to get more details about it. So let's say for this time, we are using a replication length of 50 days, number of replication to 1. Still, we have a warm-up period of, let's say, 2,000 minutes or maybe 2 days, something like that. So think in this case, we just have 2 days of data that is not being utilized, right? That is getting wasted because we want this system to reach steady state to give us the data. However, it's less than 20 days, right? So that's like give and take. So let's go ahead and click OK. Let's run the model. And let's see what Arena reports for us in the half width. So let's go to here. So total WIP is 13.6777 and half width is 1.3358. So let's go ahead and report that. So for one replication, it's 13.677, and then symbol is plus minus, and it's 1.33580. So we can see the half width is less than the half width for total WIP with warm up where we had multiple replication. So that's a good indicator. And when to use this and when to use this. If the warm up period for your system is longer, let's say it takes 10 days for statistics or for your system to reach a steady state. In that case, you really need to use batching. Like you really need to run your model for a long period of time. However, if it reaches steady state, let's say by 1 or 2 days of operation or something like that, in that case, you can just go ahead and define your warm-up period and run it for multiple times, just like terminating condition. And so that's the difference between these two. And one more thing is that for utilizing process analyzer or UpQuest, you need to have your system, you need to have more number of replication, right? At least 3 replication for running process analyzer. So if you have just one run, the worst part is that you can't use process analyzer for comparing alternative systems, because you just have data from one replication. However, if you define your steady state run with warm-up period, then it's good. You can go ahead and use process analyzer, output analyzer, or UpQuest as you desire to find out or to compare different system configurations and so on. So I hope you learned something from this tutorial, and I will definitely suggest you to read the textbook for this one, because it has elaborately described why you need steady state condition. Thank you so much for watching this video.